Top of page 395 talks about graphing linear inequalities. It's all points in the coordinate that represent solutions, and that's called a half plane. So the plane is like everything. A half plane is when we shade on one side or the other of our line. And that's, you can call a boundary line. All the solutions are going to be on one side of the line or the other, or possibly if it's greater than or equal to or less than or equal to, then it's going to include the line as well. Then we would have a solid line. If it's just like this first example here, just greater than, or if you just have less than, notice it's a dashed line, okay? Because this line right here is y equals 3/2 x minus 1. So if we just have y is greater than 3/2 x minus 1, the line is not going to be part of our solution for that problem. So if you look at problem 2, they're asking what is the graph of y is greater than x minus 2. So y is greater than x minus 2. First, we're going to graph y equals x minus 2. We're going to find some points for that, y equals x minus 2. So to do that, we would probably make a table. Okay, the book's not showing exactly every little thing that they're doing here. But like we've talked about before, if you want to pick 0, 1, and 2 for some points, if you put a 0 in place of x, so that'd be 0 minus 2, that'd be negative 2. If you put a 1 in place of x, 1 minus 2 would be negative 1. You put a 2 in place of x, 2 minus 2 is 0. So 0, negative 2, 1, negative 1, and 2, 0. And you can see that their graph's going through those points. So it goes through those points. I'm putting those dots there, but then I'm going to think about whether I'm going to include that line or not. So in this case, since it says y is greater than, and the line is y equals, we're not including the line. So that means we need to put a dotted line. Dotted line shows that we're not including the line. Kind of like whenever you graphed on a number line, when we had one variable, we did an open circle, right? Open circle didn't include the point. Dotted line does not include the line. Okay? And then what we need to do is test a point on one side or the other, because either all the points above the line work or all the points below the line work. We just need to figure out which side of the line our solutions are going to be on. So 0, 0 is a nice point to test. 0 is kind of nice to work with. So they put 0, 0, 0 in for x, 0 in for y to see if this works or not. So they substituted in, and if we did that, it says 0 is greater than negative 2. So then we have to think, does 0 greater than negative 2? Yes, it is. 0 is greater than negative 2. That means 0, 0 is a solution. So if we look at our graph, 0, 0 is up here. So if 0, 0 works and it's above the line, that means everything above the line is going to work. All right, and again, when you guys are doing your shading, how I shaded right there, that's sufficient. Okay. You don't have to get a color crayon out and color it perfectly. You don't have to have where you have to sharpen your pencil after every time that you shade on a problem. So if we look at the got it 2, they want us to graph y is less than or equal to 1/2 x plus 1. So for these, if you just start out with a piece of graph paper, and then you can make an x-axis and a y-axis. If you want to, before you make the x and y-axis, you can find some points that are going to be on your line, especially for real-life problems. Sometimes those have bigger numbers. You know, you may not want to be going by ones when we're dealing with 500 or something. That would not fit on your graph, obviously. So when we're going to graph this problem, normally we've talked about using 0, 1, and 2 for your x values. In this case, we do have a fraction here in front of the x. We have a fraction coefficient. So we might want to adjust the numbers that we use a little bit. So if we want to avoid fractions, makes things a little bit easier for us graphing. 0, I always like. Since our denominator is 2, 2 would be the next number I would choose. And then the next one after that would just be the next multiple of 2, which would be 4. If I do that, I'm going to avoid having fraction answers when I get my y values. So 0, 2, and 4 we're going to be using. So we can just ignore the inequality, ignore the fact that it says less than or equal to, and we're just going to substitute this in. So 0 in for x first. Half of 0 is 0, plus 1 is 1. That's our y-intercept, which we've talked about. If we put a 2 in, half of 2 is 1. 1 plus 1 is 2. And if we put a 4 in, half of 4 is 2. 2 plus 1 is 3. All right, so this gives me 3 points. Again, technically 2 points determine a line. 3 is a little safer because then if they line up with each other, I feel pretty confident that I've graphed these correctly. All right, so we're going to graph these points. So 0, 1, 2, 2, and 4, 3. So 0, 1, 2, 2, and 4, 3. Okay, so those should be lining up with each other when you go to graph this. So since our inequality is less than or equal to, we're going to do a solid line here. And when you guys do this, you know, if you want to use a ruler or something to make it a little bit nicer, I've got a way I can do it on here, but I'm not messing with it at the moment. That's not too bad of a line. All right, and then we need to test a point. Now we need to decide, are the solutions going to be above the line or are they going to be below the line? So if the line doesn't go through 0, 0, that's going to be a point that I want to try because it's easier to put zeros in for numbers. You could pick anything if you wanted to. You could pick 150 if you wanted to. 100, 50 as your point if you'd like. But again, I'm just going to try 0, 0 and see what happens here. Technically, when we're substituting this in and we don't know if it works or not, we really should put a question mark there, kind of like the book did, because we really don't know if this is working or not. So half of 0 would be 0, plus 1 is 1. So the question is 0 less than or equal to 1? Yes, it is. Okay, so since that's true, that means 0, 0 is a solution. 0, 0 is a solution which is below the line, and that means everything below the line is going to work here. Okay, infinite number of points down here that could work for this inequality. We can also graph inequalities if we only have one variable. In the past, we always did this just on a number line, but you could have two variables, but just one variable in the inequality, and you could still graph this. So for problem 3, part A, x is greater than -1, we could graph the line x equals -1. Just remember to graph the line x equals -1, you can do a chart, and x is always -1. If x equals -1, and then you can just put whatever y values you want because y isn't in our inequality. So if you forget, I always used to forget is it going to be a vertical line, is it going to be a horizontal line. So that's a way you can make sure you're going the right direction. And then graph your line. And once again, we can put in 0, 0. In this case, putting in 0, 0, we don't have a y to put it in for. We can just put in a 0 for the x and see if that works. 0 is greater than -1. Once again, that happens to work. 0, 0, in this case, I don't know if I would call it above or below. It's to the right of our line, and so we would shade everything to the right of the line in that case. Similar case on part B, y is greater than or equal to 2. Again, you could make a table. The equation we're thinking about, y equals 2. So y equals 2, y would always be 2, and then you put in whatever numbers for x that you want. And then if you graph, that's going to be a horizontal line. A solid line again because it says greater than or equal to. And then we're going to test the point. So again, they tried 0, 0. Again, we only have one variable there to put it in for, so 0 in place of y is 0 greater than or equal to 2. And for once, the answer is no. So 0, 0 didn't work, which is below our line. So that means nothing below the line works. So that means the solutions would be above the line. So we would shade above the line in this case. Problem 4, we've got a real life problem here. So interior decorator is going to remodel a kitchen. The wall above the stove and counter is going to be redone as shown. And the owners can spend $420 or less. Write a linear inequality and graph solutions. What are 3 possible prices for the wallpaper and tiles? Okay, so what we're looking at basically is for the tiles, we've got an area of 12 square feet. For the papered area, the wallpaper, we've got an area of 24 square feet. So the variables are, I should say, the cost per square foot. So X is the cost per square foot of the paper. Y is the cost per square foot of the tiles. If you did it the other way around, that's okay. It doesn't matter, just your X and Y is going to end up being opposite whenever you get your answer. All right, so the inequality that we could use here, we've got 24x, so 24 square feet times the cost for 1 square foot, plus 12 square feet times the cost for 1 square foot, and that needs to be less than or equal to $420. So this, we actually have 2 options. We can do what the book's doing. They subtracted 24x, they divided by 12, they got it solved for y, and then they graphed it. We talked about, they did a whole lesson on this, so I'm not sure why they're avoiding it at this point. That's in standard form. In standard form, it's going to be easier for you just to find intercepts. Okay, put a 0 for x, see what you get. Put a 0 for y, see what you get. So if you put a 0 in for x here, 24 times 0, that falls out. So we're basically left with 12y equals 420. And then if you divide by 12, then you will get 35. And then same thing, if you put a 0 in for y, we'll be left with 24x equals 420. And when you do 420 divided by 24, you get 17 and a half. Okay, so doing the intercepts like this, you might not get the nicest numbers, but it will be potentially a quicker way of going about this. One thing about that, when you go to graph that 17 and a half, make sure you go by something to where you can tell where 17 and a half would be kind of on your graph. So anyway, they graphed this. You can see on the graph the 0.35 up there. You can see that the 17.5 0. It's hard for us to exactly tell that that's that point, but 17.5 0 would be that other point. This said less than or equal to, so it's going to be a solid line. And then we need to think about the options. Sometimes in the real life problems, it's easier to think about the options if they make sense or not. Like, for example, if our budget is $420, if that's the most we can spend, would it be possible that we just don't get anything and we just decide to leave it alone? That'd be an option, right? Okay, maybe not really what we're after, not really what our intent is here, but technically 0, 0 works. That says I'm just not even going to mess with changing this stuff. Okay, so 0, 0 works. That's below the line, and so actually everything below the line is going to work. A lot of the real life problems, if money is an issue, below the line is where we're going to stay within our budget. So the guy at 4, party can spend no more than $12. Peanuts are $2 a pound. Cashews are $4 a pound. What are 3 possible combinations of peanuts and cashews you can buy? Okay, so our limit is $12. Peanuts are $2 a pound. And cashews are $4 a pound. So first thing would probably be defining our variables. So the book didn't really, well, they had let x equal, let y equal. So we're going to try and use represent instead. So let x represent pounds of peanuts, let y represent pounds of cashews. Then we can come up with an inequality to see what some different options are for us to buy. So our inequality would be 2x plus 4y is less than or equal to 12. $2 a pound times pounds of peanuts plus $4 a pound times the pounds of cashews, and that total needs to be no more than, so less than or equal to $12. Again, since the x and y are on the same side, since it's in standard form, I'm going to go ahead, I'm going to go ahead and find intercepts here. Is probably the easiest way. This one's going to look pretty good, I think, because if you'll notice, our coefficients are 2 and 4, and those we can both multiply both of those by a whole number to get to 12. So this one, the points should come out a little bit nicer for us. So if we put a 0 in for x, 2 times 0 is 0, so that just drops out. So we're left basically with 4y equals 12. We're just going to say equals when we find our points, because this would be on our line. And so that would mean y would equal 3. So 0, 3 would be 1 point on our boundary line here. Then we can put a 0 in for y. So the y part falls out, and then we have 2x equals 12. So 2 times something equals 12, which would be 6. So again, those points are really nice there for us. A lot of times in these real life situations, you're going to be staying in the first quadrant. So even though my graph, I actually made it where it was all 4 quadrants, I really just copied and pasted it. So that's why it is identical. Anyway, you're going to a lot of times just be in the first quadrant. So if you want to just make your graph in the first quadrant here, just with the positive numbers, you can do that. One thing also we want to do whenever we graph these real life ones is we want to label the x-axis and the y-axis. So this could be x-axis. This is going to be pounds of peanuts. Or if you want to say peanuts and then pounds in parentheses, you can. And then we've got pounds of cashews. Okay, so we found some points, possible points on our boundary line, 0, 3, and 6, 0. Since this was no more than, again, so we had less than or equal to, we're going to have a solid line rather than a dotted line here. So now to figure out which side of this line we need to shade on, our line doesn't go through 0, 0, so we could try that. So if we try 0, 0, so we had 2x plus 4y is less than or equal to 12. So 2 times 0 is 0, 4 times 0 is 0, 0 plus 0 is 0, lots of zeros. And then the question is 0 less than or equal to 12, and it is, and so that means that 0, 0 works, means everything below the line works. Now my line moved on me here, so get it back where it was, but everything below it works, so we would shade this part here. Now this case, actually not everything below that works. We have to stay in the first quadrant because we can't buy negative pounds of something. Doesn't make sense. Problem 5 is kind of backwards from the ones that we've been doing. So they're actually giving us a graph and they're asking which inequality represents the graph. So one thing to note, the first thing I would look at is whether we have a solid or dotted line. We do have a solid line, so that's going to eliminate some options for us. Well, it eliminates one option for us anyway. Another thing to consider is what the equation of the line is. So the equation of the line, it has a y-intercept of 1, and it looks like we're going by ones here, so they're going up 2 and over 1. So our slope is 2. So if you think about the equation, slope is 2, y-intercept is 1. So 2x plus 1 would be the equation we'd be dealing with, so we can eliminate choice B. So it's between A and C. And so it's just a matter, is it less than or equal to, is it greater than or equal to? So the line doesn't go through 0, 0, so if you want to just try 0, 0, let's just guess which one it is. So let's just look at A, and if we guess 0, 0 and see if that works, that's going to be 0 is less than or equal to 0 plus 1. So 0 is less than or equal to 1, and that's true. So that that worked, and so this should be the answer. If it didn't work, then it would be the other side. One thing I haven't mentioned to you guys, but usually if it's solved for y and it's not a horizontal line, you can kind of look at this as, if you can think of this as being shading below the line. Shading below the line, if it's solved for y, is going to be less than or equal to. If it's in standard form, we can't just look at it that way, but if it's just a y by itself, then you can do it that way as well. So the got at 5, you're writing an inequality from a graph. The boundary line is dashed, has a slope of 1/3, y-intercept of -2. Area above the line is shaded. What inequality should you write? So an equation, y equals mx plus b, we can think about the slope is 1/3, y-intercept is -2, so either -2 or plus -2. And we have a dashed line, so it's either just going to be greater than or less than. And the area above the line is shaded, so above the line, that's going to be greater than. So we could actually get by and figure out that answer without even graphing anything out if you know what you're doing. If you look at the lesson check number 2, so they want us to graph this just to get a little bit more practice here. Y is less than or equal to -2x plus 3. So if we just think of y equals -2x plus 3, we can make a chart here. No fractions, so 0, 1, and 2 should work out pretty good. If you put a 0 in for x, -2 times 0 is 0. 0 plus 3 is 3. That's our y-intercept, so you could actually just start 0, 3 automatically. If we put a 1 in, -2 times 1 is -2, plus 3 is 1. And if we put a 2 in, -2 times 2 is -4, plus 3 is -1. So these would be 3 points on our graph. So 0, 3, 1, 1, and 2, -1. And then we can draw a line. So again, if you want to make a nice line, if you use a ruler, makes things quite a bit easier for you maybe to do that. So a line would look something like that. Put arrows on both ends. Fortunately, this was less than or equal to, so we do a solid line. If it's a dotted line, you can use a ruler, draw the line, and then just erase a little bit of pieces in between to make it dotted. So this line doesn't go through 0, 0, so we can test that point. So if we try 0, 0, 0 is less than or equal to that'd be 0 plus 3. We're testing this, so we should put a question mark there. So is 0 less than or equal to 3? The answer is yes. So we would shade on that side. Okay. And again, if you can think of that as being below the line, since it said less than or equal to, shading below the line, since the y is by itself in our inequality. Number 3, they want us to graph this, and this is one that just has the one variable in it. So x is less than -1. So if we make a table here, think of x equals -1. If x equals -1, x is always going to be -1. And you can put in whatever values you want for y. So these would be some points that would be on that line. So -1, 0, -1, 1, -1, 2. All right, again, if you just know that, that's fine. If you just remember that's going to be a vertical line. Again, I always got confused on that. This one is just less than, so it's going to be a dotted line. So you can just draw a dotted vertical line there. And then we can think of, again, 0, 0 is a point we can try that's not on our line. So if we try that in our inequality, we've got 0 is less than -1. Is 0 less than -1? And the answer is no. 0, 0 would be to the right, and that didn't work, so we would shade everything to the left of the line. And again, this one, I mean, it kind of makes sense if you think about it. The left of that line, all of our x values are less than -1 for any point. on that side of the line. If we look at number 4, they're asking what the inequality is that represents the graph. So again, we started with the graph and then they want the inequality. So again, if we want to figure out the line here, we want to look for our y-intercept, which is -1. We want to look for our slope. They're going by ones here, so we could go up 1 and over 2 would get us to another point. So our slope is 1/2. It's a dotted line, so it's just going to be greater than or less than. Since they're shading below the line, it is going to be less than. And again, you could check yourself with that. You could try 0, 0, and 0, 0 shouldn't work. Okay, 0 is less than -1. That's not true. So 0, 0 above the line. We didn't shade above the line, we shaded below the line. So we know this would be our answer for that inequality. So this gives you an idea of how to work with linear inequalities.